Welcome back. In this lesson, we're covering strings and vectors, the two most common standard library types you'll use in C++. Strings handle dynamic text. Vectors handle dynamic lists. Together, they cover the majority of data you'll work with in beginner and intermediate programs. By the end, you'll know how to create, modify, and iterate over both types, and you'll have practical patterns for text splitting, averages, and parsing. Let's get started. A string in C++ is a dynamic sequence of characters that manages its own memory. You create one with std string, text equals hello. You can append to it with the plus equals operator, text plus equals space world. Now text contains hello world. Two operations you'll use constantly, find and substring. Text.find of world returns the position where the word starts. Text.substring of 0,5 extracts the first 5 characters, giving you hello. Find and substring cover a huge amount of practical text work before you need more advanced parsing. And because strings manage their own memory, you don't need to worry about allocation or cleanup. If string is the default type for text, vector is the default type for everything else. A vector is a dynamically sized, contiguous array. You create one with std vector of int scores, then brace initialize with 10, 20, 30. To add an element, call pushback, scores.pushback of 40. Now the vector contains 4 elements. Contiguous means the elements sit next to each other in memory, which makes vectors cache-friendly and fast to iterate. They work naturally with algorithms and range-based loops. Here's the rule. If you're not sure which container to use, start with vector. You'll be right most of the time. The cleanest way to loop through a vector or string is the range-based for loop. For const, auto-reference score, :scores, then print score. The const means we're not modifying the element. The auto-reference avoids copying. The colon means for each element in the container. This syntax works with vectors, strings, arrays, and any standard container. No indices to manage, no off-by-one errors, no risk of going past the end. Range-based for is the default iteration pattern in modern C++. Use indexed loops only when you specifically need the index. Let's put it together. This program calculates the average of a vector of integers. We create a vector called values with 6 numbers: 4, 8, 15, 16, 23, 42. We declare a sum variable initialized to 0. Then we loop through every value in the vector, adding each to sum. Finally, we print the average, sum divided by values.size. Values.size returns the number of elements as an unsigned integer. This is a pattern you'll use constantly. Create a collection, accumulate a result by iterating, then produce output. Clean, readable, and idiomatic C++. Here's a practical pattern that comes up all the time. Splitting a delimited string into pieces. We create an iString stream from the text Ada, Biana, Grace. An iString stream lets you treat a string as if it were an input stream, just like cin. Then we call getLine in a while loop, passing the stream, a token variable, and the comma character as a delimiter. Each iteration extracts text up to the next comma. The output, Ada, Biana, Grace, each on its own line. This pattern works for CSV fields, configuration values, or any text separated by a known delimiter. It's simpler than writing your own split function, and it handles edge cases well. 3 principles to carry forward. First, prefer vector over manual dynamic arrays. C-style arrays with new and delete are error-prone and unnecessary in modern C++. Vector handles allocation, resizing, and cleanup automatically. Second, pass large strings and vectors by const reference. Writing const vector of int reference scores as a function parameter avoids copying the entire container while preventing modification. Third, use range-based for loops for clean iteration. They're safer, shorter, and clearer than index-based loops. These 3 habits will make your code more idiomatic and less bug-prone. Vectors grow automatically when you add elements, but each growth may require allocating new memory and copying all existing elements. If you know roughly how many elements you'll store, call reserve up front. Vector of string names, then names.reserve 100. This pre-allocates space for 100 strings without adding any elements. When you then push back into the vector, it uses the reserved space without reallocating, until you exceed the reserved capacity. This matters for performance in tight loops and for avoiding iterator invalidation, which we'll cover in a moment. Reserve is cheap insurance against repeated reallocations. 2 ways to access vector elements. The bracket operator, values bracket 0, gives you the first element with no bounds checking. It's fast, but if the index is out of range, the behavior is undefined. Your program might crash, or worse, silently read garbage. The at method, values.at0, does the same thing, but with bounds checking. If the index is out of range, it throws an exception. Use brackets when you've already validated the index or when performance is critical. Use .at when safety matters more than speed, especially during development and debugging. In practice, range-based for loops avoid the question entirely. No index, no bounds issue. 2 important concepts for working safely with strings and vectors. First, string view. It's a lightweight, non-owning reference to a string. You can read through it, but you don't own the underlying data. The original string must stay alive as long as the view exists. If the original string is destroyed or modified, the view becomes a dangling reference. Use string view for function parameters when you only need to read, not modify, the text. Second, iterator and reference invalidation. When a vector grows and reallocates, any pointers, references, or iterators pointing into it become invalid. In this example, we take a pointer to the first element, then push back a new value. If the vector reallocated, that pointer now points to freed memory. This is one of the most important vector rules to remember. Let's combine strings and vectors in one program. We start with a string containing space-separated numbers, 10, 20, 30, 40. We create an iString stream from that string. We declare a vector of integers and reserve space for 4 elements. Then we loop. Extract integers from the stream with the extraction operator and push each into the vector. Finally, we print the count. This pattern, text input, pass into typed values, store in a vector, shows up constantly in real programs. Configuration files, command line arguments, log processing, data import. The iString stream bridges text and typed data, and the vector accumulates the results. Before moving on, 2 modern string features worth knowing. The ends with and starts with methods added in C++20, let you check string prefixes and suffixes cleanly. Path.ends with .md tells you whether a file path is a markdown file. No more manual substring comparisons. Looking ahead, once vectors and strings feel comfortable, start replacing manual loops with standard algorithms. Ranges sort, ranges find, and ranges transform express intent more clearly than handwritten loops. For next topics, continue with classes and structs to learn how to define your own types. Then, memory and ownership to understand how C++ manages the lifetime of data. Strings and vectors are your everyday tools. Now let's build the types that use them. Thank you.